Okay, good morning, good afternoon, everybody. It's 11. It's time to start our webinar. So that's a webinar that has been prepared by CySec in collaboration with AMD, and where you will learn how to run your application securely in public cloud. And we will show you an example by combining a solution from CySec called ARCA and AMD Secure Encrypted Virtualization. Those two solutions running on Google Cloud Platform. So for this webinar, we will have two speakers, and I'm the moderator. So my name is Mathieu Legret. I'm the VP product of CySec. We have the chance today to have one person from AMD, Patrick Mas, and the CTO from CySec, Alexander Karlov. So Patrick, could you please introduce yourself and say a few words about your company, please?
Thank you very much. Hi, everyone. So I'm Patrick Mas. I'm a cloud and data center cloud solution architect. So I'm working for AMD. I will present today the AMD-powered cloud confidential computing solution that you have in the Google Cloud, and that is leveraged by CySec. As you may know, AMD is producing EPIC processors for data centers, and we are leveraging a feature that is existing in all the processors that we have for data centers. So this is something that is quite general, and that we will be quite interesting to see how easy it is usable in the industry, in the cloud.
So thank you, Patrick. Alexander, can you introduce yourself, please?
Yep. Hello, everyone. My name is Alexander Karlov. So I'm CTO of CySec. I'm in charge of engineering, product development, and all the technological aspects of what CySec is doing. And yeah, among other things, ARCA Trusted OS, the operating system I will be presenting you today.
Okay, thank you, Alexander. So I will start with just a few sentences about CySec. So we are a small company, a startup. This company was founded in 2018. So you see, we are still very young, but we have a lot of experience in our team, especially in security applications, more than 10 years. This team is composed of 25 people, 25 employees. Most of them, they are based in Switzerland, in Lausanne, but we have opened a French branch with only one employee for the moment, but we expect to make it grow because we would like to address the European market specifically. Okay, so now let's have a look to today's agenda. So we will start with introduction about the challenges of data security and how AMD would like to address, at least some of those challenges. Then the second part will be given by Alexander from CySec, and he will show you how CySec can leverage the technology provided by AMD and also use its own technology in order to provide a confidential computing environment in the cloud, so on Google Cloud Platform, for your workloads. Then there will be two short videos to show you how you can deploy our solution in Google Cloud Platform, and how easy it is, let's say, to interact with our platform when you have deployed a cluster of applications. And then, of course, we will end this webinar with a Q&A session. Please don't hesitate at any time when you have a question to type it and to send it through the question tab, let's say. Okay, so let's start with Patrick.
Thank you, Matthew. So what are the main concerns nowadays with regard to data security and privacy? Is it the lack of expertise? Is it the difficulty to follow regulation changes? Or is it the difficulty to cope with the security breaches and their implied costs? As you know, this is all about this. And to solve this, the first thing to do is to revisit your approach to data security and privacy. Next slide, please. And for this needs to review. This review needs to be done having the different local data sovereignty regulation in mind. In Europe, as you know, we have the GDPR, the General Data Protection Regulation, which is well controlled by the European Union. And we know about several fines that non-compliant enterprises had to cope with. However, there is an increasing number of governments and regulation bodies who can legally compel enterprises to share customer data, such as the US Patriot Act, the US Cloud Act, and in China, the National Intelligence Law. And similar laws around the world exist around those lines. You may have complementary roles, such as in Europe, Schrems 2, that helps you to further protect from such external territories regulations. But the concerns stay valid. And this is where, with AMD-based technologies, Google Cloud helps end users feel more confident doing business with companies who adhere to these compliance requirements. And we have already two customer examples in Europe. First is the case in the telecom industry with an European telecom service provider who was considering moving their billing processing to the cloud. Given the privacy sensitivity of call data records, GDPR compliance was a core requirement. And the use of coffee computing and coffee VM has lifted all concerns and has allowed this telecom service provider to move his billing processing to the cloud in a secure and data privacy protecting manner. Second, we have another case in the banking FSI domain. In North Europe, a modern cryptocurrency payment processing company had to comply not only with GDPR, but also to a more strict local regulation. Any move to the cloud was first denied by the internal auditors, but this denial has been dismissed as soon as official VM deployment has been considered. So we have already examples of production deployments nowadays using official computing. So let's move to the next slide to further understand what that means. So as in general, as we know, data may be either in transit, moving from one location to another over the network, either at rest, staying, stored somewhere, and per default, and this is the case in Google Cloud, in those cases, data encryption will be done per default. Data use, it's another story. By data in use, I mean data during processing. That's data that is being either stored, searched, or indexed by a given application. This is where the challenge resides about how to protect data in that case. Next slide, please. This is where official computing are meant for, protecting data while they are being accessed by applications. Creating official VMs is a simple lift and shift when using Google Cloud and AMD technology. And this solution is not restricted to certain use cases or particular workloads. It can be used by any applications that require confidentiality in the cloud. No code change is required. It's just a matter of checking the official compute box when launching your application in a VM or in a Kubernetes node. When using cloud offerings, performance is always a question. And as a matter of fact, with confidential VMs, you can expect similar performances to standard N2D or C2D instances. Now I will leave the floor to Alexander Karlov to present how SciSec is delivering this confidential VM solution.
Okay, so
yeah.
if I may, so now we have a pull question. There is a kind of short break in the sense that we would like to gather some information from the audience. So I see that now the question is, you can see the question. So in which time frame do you plan to migrate your workloads to the public cloud? This is just on our side to understand how ready, let's say, the audience is compared to the migration of workloads in the public cloud. So there are 4 possible answers. Please answer this question so that we have a better understanding of the audience we are talking to. Okay. So now you see again my screen and my presentation, and I will leave the floor to Alexander. So with the first slide, thank you.
Thank you, Matthew. Thank you, Patrick. Yeah, so in this part, I will go more into details of how SciSec leverages security features provided by AMD, by AMD CPUs, and also by Google in order to deploy a secure and trusted operating system on the cloud on the cloud provider. Let's start by really identifying the problem that we are trying to solve. So Patrick presented already that the fact that AMD, so the AMD EPYC CPUs isolate virtual machine guests from the hypervisor and from the host. So the goal really here is to isolate the workloads from the cloud service provider, and that's what Patrick was referring to as protecting data in use. It's called confidential computing, etc. So I really concentrated in protecting the workloads while the data is processed from the cloud service provider and from the cloud service provider host. But actually, there are more tricky details in confidential computing, and yeah, Patrick said that things can appear that it's as simple as checking the right checkbox. We'll see that it's a bit more trickier than that, in the sense that if we want to achieve really a high level of security, there are some measures that should be taken care of. So for instance, one of some issues that we have in the confidential computing is that how we trust the virtual machine image from the beginning, how we continue to trust the virtual machine after subsequent reboots, how do we prevent any rootkits, backdoors, and Trojans insertions into the VM or into the VM firmware, and some more classical, let's say, problems. What about the data at rest when the virtual machine is turned off? Let's go to the next slide, please. And here let's take a look briefly at the threat model against which we would like to protect with ARCA Trusted OS. We have basically 2 types of attackers that we are considering in our approach. First type of attacker is the one which is able to exploit the vulnerable application. For example, many of you have heard about the Log4j vulnerability, which is recently discovered. So imagine that an attacker is able to take control of the vulnerable application, the control flow and the execution. And the attacker's goal will be to try to either to compromise either other applications, which is called pivoting, or even taking the privileges of the virtual machine itself, so gaining administrative control. And the second type of attackers that we are considering is actually the cloud service provider itself. So we imagine a scenario where the administrator of the cloud service provider host or any other parties would like to see what's happening inside the VM and yeah, what's data is being processed, access to data, etc. when it's running and also when it's stopped. So the AMD-SEV security features are actually aimed at protecting against this second type of attacker. But then at SciSec for ARCA Trusted OS, we are putting many components together, such as actually key management, full disk encryption, root of trust concepts, secure boot, in order to achieve actually protection against all these classes of attackers. Next slide, please. So Google Cloud Platform is offering two types of features. One is called confidential VM service, and another is called shielded VM. So the confidential VM service, it's what we've been talking about, is the fact of encrypting the virtual machine memory from the host and from the hypervisor. And the shielded virtual machine offers several interesting features, such as secure boot, which helps actually to protect virtual machine instances from different malwares, rootkits, and boot level types of attacks. A virtual trusted platform module, which can be used to ensure integrity protection and to offer key management and key protection for cryptographic keys. Integrity monitoring, which monitors the runtime integrity of the virtual machine. And actually, yeah, one can wonder whether it's just a matter of checking those checkbox and having all the security features turned on. And actually, there are several images of course, on Google Cloud Platform, which support confidential VM and shielded VM. For instance, Red Hats use Ubuntu CentOS. And yeah, as I said, the question is, so we just need to check the right checkbox, and we have the necessary level of security. Next slide, please. And yeah, as I said at the beginning, as I hinted at the beginning, it's a bit much more trickier than that. So what we see on most of those default or by default virtual machine images is that disks are not encrypted by default. So there is no confidentiality of data when the VM is turned off. On many instances or tutorials or guidelines or scripts for deployment, the secure boot is turned off by default. So you can see a screenshot from, I think, from Trend Micro with the recommendation of deploying shielded VMs, where the secure boot is a sort of optional feature. And of course, if you turn on secure boot, the virtual machine bootloader has to support it. The integrity monitoring is a sort of a passive way of telling if something is wrong, and unfortunately, very often it's already too late. And well, in all those virtual machine images, much of trust is still put into the cloud service provider, Google in this case. We go to next slide. So how do we actually improve the security level and provide more security features and hardening in case of our operating system? So at SciSec, we developed our own customized operating system, which is a sort of micro distribution. So it's not a full-fledged operating system as usually you see around on providers of generic distributions. It's more of a specialized, secure operating system aimed at deploying some specific types of workloads. But first, let me tell you about the security features that we have in place for ARCA Trusted OS. So first, we have what we call an extended secure boot. So it's something similar to a secure boot, but which goes to the up to the partitions and to the file system level. So first we are provisioning our own keys into the bootloader, which is referred to UEFI or OVMF on cloud platforms. Also, extended secure boot means that if any component of the secure boot chain is tampered or loses integrity, basically the boot process just crashes. So there are no recovery shells or anything which would allow to access the data. And then, as I said, why extended? So because at the end the operating system image is also verified. So if all the stages are okay and are checked, then we start verifying operating system images. Full disk encryption means that the keys which are encrypting the partitions of the operating system are unlocked only, and the data is decrypted only if secure boot checks are validated from the integrity perspective. That's yeah, to say that if you have an ARCA Trusted OS virtual machine which boots up successfully, it means that you have the notion of trusted computing base, and you have a trusted environment where you can deploy your applications. And just a few words. So as I said, the deployment of applications, so contrary to any other operating system, you cannot install anything on the host itself. The deployment is happening through Kubernetes layer. So we have Kubernetes layer integrated on the ARCA Trusted OS VM, which is a modern deployment, scalable, cloud-friendly, and yeah, secure. Next slide, please. A few words, which actually, so speaking about the Kubernetes layer, brings me to say a few words about the isolation layers that we have in place. So as I said, so now we are considering the upper layer, so the attacker which tries to compromise a vulnerable application and tries to go around attacking other workloads and eventually the host. So we are basing on the deployment layer on the Kubernetes, which is a modern container scalable orchestration system with many options for automation, scaling, management, security, and of course by default the Kubernetes uses a runtime called runc, which you also can use by default when deploying on ARCA Trusted OS. However, we are also providing a hardened runtime called gvisor, which actually so for a typical standard Kubernetes deployment, the attacker, in order to go down to the host layer, has to exploit the vulnerability in the kernel host. That's what happened recently with some CVEs, one which was quite recent, a couple of weeks ago. So in order to prevent that and put more isolation in place, we are also using as an optional feature a hardened runtime which is called gvisor, which acts as a proxyifying layer for syscalls, and actually an attacker, additionally to exploiting the host kernel, has to exploit gvisor. And gvisor, that's a project from Google, where Google spends a fair amount of time to actually to assess the security. So it's an open source project where people actually perform quite some research to find the vulnerabilities before the attackers find them. And recently, we're also we'll have a new release of our ARCA Trusted OS operating system with a feature called kata containers, which is quite interesting because it allows actually to put even more isolation in place, because in the case of kata containers, the workload is deployed in its own virtual machine, in its own small virtual machine on the hypervisor. It means that in this case, the attacker has to exploit the guest kernel of this small virtual machine, hypervisor itself, and then the host kernel. gain privileges on the host. Kata containers also allow actually running workloads in its own confidential context, leveraging AMD-SEV feature. So in this case, even achieving the protection of workload against the ARCAOS host itself. So we have sort of double protection. Next slide, please. So to summarize, what's ARCA Trusted OS? It's a trusted computing base for cloud deployments, for cloud workloads. We build everything from source, so we have a complete control on our pipelines, tool chains. We build everything in-house. Actually, we don't build, we don't rely on any cloud service. We build it on our bare metal servers and our own data center. So we control what kind of software versions, features, what kind of kernel features we are putting in place. It allows us to reduce the attack surface. So I think we are using something like 10% of the standard Linux kernel in our operating system, and to have a minimal system images for also for an easier maintenance and quicker updates. Next slide, please. So to end up, I just want to say a few words actually about the integration of ARCA Trusted OS into the Google Cloud Platform ecosystem. So even though you won't find the ARCA Trusted OS image on Google Marketplace yet, we're still firmly integrated into the Google Cloud Platform ecosystem. So we have easy installations from our custom images. And as I said before, the disk encryption comes from the beginning. So we have a by default disk encryption for arbitrary virtual machine disk size. We have cloud init with some features. We're supporting Google load balancers, so it's quite transparent. So you have your own cluster with the possibility to rely on Google Cloud Platform load balancers. We have also the possibility to use Terraform for deploy a large number of nodes very quickly. And we are also relying on guest agent for scripts, network, and OS login. So it's, yeah, to say that we are quite well integrated into the Google ecosystem, and we are hoping that soon we will be also on the Google Marketplace. That's on my side, and I pass to Matthew.
Okay, thank you very much, Alexander. So now it's time for the demo. So again, it's really the combination of ARCA Trusted OS, so the solution and the platform solution from SciSec, and running in a confidential VM provided by AMD. Oh. I'm sorry, I need to pause. Yeah, so this first demonstration, it's a very short one. It's just to show you how we deploy ARCA Trusted OS in GPU, so in Google Cloud Platform. It's very short, and you will see it's really simple. It's one way to deploy, let's say, through the graphical user interface provided by GCP. Of course, we can do it much faster, even with just a few command lines. So for those of you who are used to play, let's say, with Google Cloud Platform, that's the normal interface. And let's start video. So we want to create a new instance. So of course we need to give a name. That's quite obvious. Then we choose confidential VM. That's important. And we need to download an image of the OS. So in this case, we go in a specific, we select our custom image, so of ARCAOS. And we just select. And the last step that is important now is to manage those security settings. And you see, we need to turn on the secure boot. So again, the secure boot, when we are talking about the secure boot of Google, is just checking the integrity of, let's say, at the boot level and the kernel level. In our case, we use the same, let's say, option provided by Google Cloud Platform to also check the integrity of the operating system. So the system file before, let's say, launching our platform. Okay, then the second video is about, it's to show you an application running on ARCA. So there is a Kubernetes cluster deployed on ARCA in confidential VM, again on Google Cloud Platform. So we start with this, the same graphical interface, just to show you that we set up some instances called ARCAOS. So that's how we call our VM instances. We just check the settings. So as you can see, we run, yes, and we'll just pause. Try to pause, but okay. So sorry for the break. So now we will just log on ARCAOS Trusted OS. So as you can see, it's a standard Linux interface. We see the SciSec logo, and we will check what is running. If you don't see, please zoom in. This is what I wanted to say when I wanted to pause the video. If you don't see the details, please zoom in. I cannot zoom in. So what we see now is that there is a Kubernetes cluster running on ARCA Trusted OS, which is fine. So for the moment, Google Cloud Platform, they don't support, let's say, the remote attestation. So it's difficult, let's say, to check if we are running on AMD-SEV, but that's always, let's say, possible. We just can check if this AMD memory encryption feature is activated or not, and this is the case. Okay, so this means that that our instance is running on Google Cloud Platform in a confidential VM. So now we have this Kubernetes cluster, and there is one application running on it. It's just a chat application. So the name of this application, you might know it. It's Rocket Chat. Again, it's just for the demo. It's not a concrete use case. So we have this chat application that is deployed on this Kubernetes cluster, and to join or to log on this this application, we need to follow the typical workflow of a Kubernetes cluster. So using ingress controller in this case. And we need to look for the public address of this controller. And so this is what we will do right now. So that's the next command. So we will ask for the public address of this ingress controller. We just copy it, and now we will log on our application. Okay, so if you are familiar with this application, Rocket Chat, you see, I mean, there is no change. It's the same interface. And we are running this live chat in a confidential VM and on ARCAOS, and we do this in a transparent manner, let's say. We didn't have to change anything, any code in the application. Okay. And I guess, yes, that's the end of this video, and that's the end of the demonstration. So now it's time for the Q&A session. I will check if there are questions. So don't hesitate to ask questions in the chat. I don't see any questions for the moment. Nevertheless, I will ask a question first to Patrick. So Patrick, we have presented let's say the AMD-SEV feature deployed in Google Cloud Platform. Can you say a few words about let's say the availability of AMD-SEV second and third generation in other public cloud service providers, please?
Yeah, sure. So AMD EPYC processors, so either second generation or third generation, are present in the majority of the cloud service provider that you have. So we have in Google N2D and C2D that I mentioned about that are standard for the N2D, that are standard general purpose instances, or C2D that for compute optimized resources. Both instances can be used for coefficient compute, as I mentioned. In the complement, in the Google Cloud area, we have TOW VMs T2D, which is meant to really burst for cases where you are sensitive in bursting your workloads in the cloud and having the best performance per core per thread. For example, in this T2D, we are using the physical core directly. So it's quite interesting when it comes to performance per thread or per vCPU here being the physical core. So it's an example of the usage and the integration of AMD CPUs nowadays. We are existing in the major hyperscalers. So in terms of AMD-SEV feature sets, you have that with different hosters in France, in Germany, and also in the big ones. You will have that including in commercial VM offerings in Microsoft Azure, where you will have existing today, you have a preview of commercial VM, which implements not only SEV and SEVES encrypted states for encryption of CPU registries, which is adding even more security. We have the latest features, which is even better from a side attacks perspective. And this is called SEV SNP for secure nested paging, which is further securing you against attacks from the OS, from the hypervisor, or from side virtual machines or containers. Does that answer your point?
Thank you very much, Patrick. So in the meantime, Thomas sent a question. Can I use Microsoft Azure instead of GCP? So maybe Patrick, you can start, and then Alexander will say a few words concerning SciSec.
So from as I just said, indeed, Microsoft Azure has made available a preview of confidential VM that leverage AMD-SEV and up to SEV, SNP, and attestation, the notion of attestation as well. So this is available today. I will encourage you to make a try with the preview.
Okay, thank you.
Yeah, sure. So I mean, Patrick already answered the question. So yes, Azure has a preview. I think it's not yet in the fully production mode as with Google, but so this is something we're looking at currently. So deploying also ARCA Trusted OS on Azure. As you saw during my talk, we need some set of features so combined in a smart way to guarantee the high level of security. But the answer is, so for what concerns ARCA Trusted OS, we are looking into it, and we are looking forward to bringing it also on Azure. And in general, I would say concerning confidential computing at large and AMD-SEV in particular, it will be coming to I would say to almost all major cloud providers. I think Patrick hinted at this, but from my perspective, yes, we'll see more and more possibility to run confidential VMs at big cloud providers and well, smaller ones as well.
Okay, thank you. So there is a question from Luca. Can ARCA support any type of container-based workloads? So it's for Alexander.
Yeah, sure. I mean, if you're considering once again, as I said, we have a standard Kubernetes layer running on top of ARCA Trusted OS. So it's really a standard Kubernetes without any modifications. So you can deploy any components, build your clusters in a way you'd like, and deploy well any containerized workloads as you would do it with I mean with the Google Kubernetes engine or any other Kubernetes engine on the cloud provider, or even your own Kubernetes cluster.
Okay, thank you, Alexander. So I don't see any more questions. We are okay, just 4 minutes before the end. So I guess it's time to wrap up. So I would like to thank the audience for attending this webinar. Of course, if you have any question to ask to SciSec or to ask to AMD, please, you can note those email address. Don't hesitate to send us your question to get in contact with us if you want to know more about our solutions. I would like also to thank our two speakers, so Patrick from AMD and Alexander from SciSec. We expect to provide some other webinars in the future on similar topics, confidential computing, and let's say trusted execution environment. So we will send you information when they will be ready and scale. Okay, thank you very much for everybody for your attention, everybody, and we keep in touch, and we hope that we will talk to you soon. Thank you. Bye bye.
Thank you. Bye.